button to subscribe my channel and also click the bell icon to get notifications of all my latest uploads. Thank you.
Hello friends, welcome to my channel. In this video series, we are discussing Set B of NDA-II 2017 question paper. We have discussed till question number 36. Now we will discuss question number 37 onwards. So let us start with question number 37. If we define a relation R on set n cross n as AB, RCD gives A plus D is equals to B plus C for all AB, CD belonging to n by n, then the relation is. In this question, we have to tell whether the relation is symmetric, reflexive, symmetric and transitive, or equivalence relation. So let us see. We are given AB, R, CD. This gives A plus D is equals to B plus C. It means A plus D and this one is B plus C. So let us check for reflexive relation. For reflexive we have AA, R, AA. So A plus A, these two A's are equal to these two A's. So the relation is reflexive. For symmetric we have AB, R, AB. So A plus B is equals to A plus B. So the relation is symmetric. Now let us check for transitive. For transitive we have AB, RCD and CD, R, EF. Then it should satisfy AB, R, EF. So let us check. For these two we have A plus D is equals to B plus C. And for these two we have C plus F is equals to D plus E. Now if we add these two, we will get A plus D plus C plus F. Left hand sides will be added. Similarly right hand sides will be added. So B plus C plus D plus E. Now this D and C, they will get cancelled and I have A plus F is equals to B plus E. And this gives ABR EF. So the relation is transitive. It means in total this relation is, since the relation is reflexive, symmetric and transitive. So this is an example of equivalence relation. And this matches with option C. So option C is the correct answer. Let us now see question number 38. If y is equal to x plus x square plus x cube plus up to infinite terms where x is less than 1, then which of the following is correct? So let us check. We are given this is an infinite series. Y is equals to sum of infinite series is a, that is the first term, divide by 1 minus r. R is the common ratio. Common ratio here is x. This gives me y into 1 minus x is equals to x, or y minus yx is equals to x, or y is equals to x plus xy, or y is equals to, if I take x outside, this will be 1 plus y, or we can say x is equals to y upon 1 plus y. And this matches with option A. So option A is the correct answer. Let us now see question number 39. If alpha and beta are roots of the equation 3x square plus 2x plus 1 equal to 0, then the equation whose roots are alpha plus 1 upon beta and beta plus 1 upon alpha is. So in this question we need to frame a equation. Equation is equals to x square minus sum of roots into x plus product of the roots is equal to 0. Here sum of roots means this root plus this root. So sum is equals to alpha plus 1 upon beta plus 1 upon alpha. This gives alpha plus beta upon alpha beta. And alpha and beta are the roots of this equation. So sum of roots alpha plus beta is equals to, this is minus b upon a, so minus 2 upon 3, and alpha into beta, product of roots, is 1 upon 3. So let us substitute these values. This will be minus 2 upon 3 plus minus 2 upon 3. Alpha beta is 1 upon 3, so 3 will go to the numerator, these 2 will get cancelled, and this will be minus 2 upon 3 minus 2, this gives minus 8 upon 3. Similarly, product of roots is equals to alpha plus beta multiplied by beta plus 1 upon alpha. So this gives alpha beta plus 1 plus, this is 1 upon beta, sorry. So this is alpha beta plus 1 plus, this is 1 plus 1 upon alpha beta. So this is alpha beta is 1 upon 3, so 1 upon 3 plus 2 plus, this will be 3. So 1 upon 3 plus 5, this gives 16 upon 3. So let us substitute these two values here. We will get x square plus 8 upon 3 x plus 16 upon 3 equals to 0, and this gives 3x square plus 8x plus 16 equals to 0, and this matches with option A. So option A is the correct answer. Let us see question number 40 now. Upon log to the base 3e plus 1 upon log to the base 3e square plus 1 upon log to the base 3e4 up to infinite terms is. In this question, we need to find the sum of this series. For this, we will be using log formulas. One of the formula is, if we have log to the base a, b, this equals to 1 upon log base b, a, and also log a, b raised to the power m. This is equals to m log base a, b. So we will be using these two formulas here. So let us use. This is 1 upon log 3e. This can be written as log to the base e 3 upon 1 plus log to the base e 3. This 2 will come to the denominator, plus this will be 1 upon 4 log e4 plus, like this up to infinity. Now in this series, if I take log e3 out, so this is log e3, this is 3. Log e3 out, I will be left with 1 plus 1 upon 2 plus 1 upon 4 plus, like this up to infinity. Again, this is an infinite series, and sum of this series is given by log base e3. Sum of this series is a, that is the first term, this is 1 upon 1 minus r, where r is the common ratio, and in this question common ratio is 1 upon 2, so 1 upon 2. This will give log e3, this will be 1 upon 2, 2 will go to the numerator, and we can say this equals to log e9, and this matches with option A. So option A is the correct answer. Let us now see question number 41. A tea party is arranged for 16 people along two sides of a long table with 8 chairs on each side. 4 particular men wish to sit on one particular side. The number of ways they can be seated is. Here, suppose this is a long table and there are 8 seats this side and 8 this side. 4 particular men want to sit this side and 2 particular men want to sit on this side. So the 4 people on one side choose out of 8 4 places. So 8 C4. Similarly, out of 8 places, these 2 will be chosen by the 2 people. So out of 8, they will choose 2 places. And these 4 places, they will permute amongst themselves. So that will be 4 factorial. Similarly, these 2 people will permute among themselves 2 factorial ways. Now, out of 16 places, 6 has been used. 10 are left. So the remaining people will occupy these 10 places. That is 10 factorial ways. So the total number of ways are, this is 8 factorial upon 4 factorial. 8 minus 4, that is 4 factorial. Similarly, this is 8 factorial, 2 factorial, 8 minus 2, 6 factorial into 4 factorial into 2 factorial into 10 factorial. Now this 4 factorial and 4 factorial will go, 2 factorial and 2 factorial will go, 10 factorial can be written as 6 factorial into 7 into 8 into 9 into 10. So this 6 factorial and 6 factorial will go. I am left with 8 factorial into 8 factorial into 7, 8, 9, 10 divided by 4 factorial, that is 4, 3, 2 and 1. This 4 and 2 will get cancelled with 8. This will be 3 here. Now 7 3s are 21 and 10 210. This equals 210 into 8 factorial whole square. And this matches with option C. So option C is the correct answer. Let us now see question number 42. The system of equations kx plus y plus z equal to 1, x plus ky plus z equals to k and x plus y plus kz equals to k square has no solution if k equals. In this question, for no solution, the value of determinant should be 0. So let us take, this is k1, 1, this is 1, k1, this is 1, 1, k. Value of this determinant should be 0. So let us find the value of this determinant. This equals k, this is k square minus 1, then minus 1, this will be k minus 1, then 1, this will be 1 minus k, plus 1, 1 minus k. Value of this determinant should be 0. If I take k minus 1 outside, so k minus 1, here I have k and k plus 1, from this minus 1 and from this minus 1. So this gives k minus 1, this is k square plus k minus 2. This equals 0. It means either k is equals to 1 or this can be written as k plus 2 and k minus 1. This gives either k is equals to 1 or k is equals to minus 2. So if I put k is equals to 1, then these two equations become same. So the value for k will be minus 2 and this matches with option D. So option D is the correct answer. Let us now see question number 43. 1 multiplied by 3 plus 2 into 3 square plus 3 into 3 cube, like this up to n into 3 raised to the power n is equals to 2n minus 1 3 raised to the power a plus b upon 4, then ABR. So these are options n2, n3, n plus 1 2 and n plus 1 3. Let us solve this question by options. So for that, let us put n is equals to 1. Then left hand side is 1 only, that is 3. And on right hand side we have, this is 2 into 1 minus 1 upon 4. This is 3 raised to the power a plus b. So this gives me 3 4s are 12. So 12 is equals to, this is 2 minus 1, that is 1. So 3 raised to the power a plus b. And let us check which option suits this value. If I put n is equal to 1, this becomes 1 2. So if I put 1 and 2 here, this will not match. If I put n is equal to 1 here and 3 here, so 3 plus 3 9 not match. Then 2 2, 3 raised to the power 2, 9 plus 2, this will not match. This is 2 3, if I put 2, so 9 plus 3 12. Yes, this matches. So option D is the correct answer. Let us now see question number 44. In triangle PQR, R is equals to pi by 2. If tan p by 2 and tan q by 2 are roots of the equation ax square plus bx plus c is equals to 0, then which one of the following is correct? A is equals to b plus c, b is equals to c plus a, or c is equals to a plus b, or D is b is equals to c. So let us draw triangle PQR. Suppose this is triangle PQR. Right angled at R, this is R, this one is P and Q. In this triangle, it is given that angle R is pi by 2. So P plus Q is also equals to pi by 2. So P plus Q is pi by 2. And it is also given that tan p by 2 and tan q by 2 are roots of this equation. It means sum of roots, that is tan p by 2 plus tan q by 2, this is equals to minus b upon a. Or product of the roots, tan p by 2 into tan q by 2, this is c upon a. Now tan p by 2 plus q by 2, this equals tan p by 2 plus tan q by 2 upon 1 minus tan p by 2 into tan q by 2. Or tan p by 2 plus tan q by 2, this is minus b upon a, so this will be minus b upon a upon, this is 1 minus c upon a. This gives minus b, this will be a minus c, and a will get cancelled, so minus b upon a minus c, or we can write b upon c minus a. And on left hand side, p by 2 plus q by 2, this is tan p plus q upon 2, or p plus q is pi upon 2, so this will be tan pi by 4. So tan pi by 4 is equals to b upon c minus a, and tan pi by 4 is 1, so this equals 1. This gives b is equals to c minus a, and this gives c is equals to a plus b, and this is our option number C. So option C is the correct answer. Let us see question number 45 now. If z minus 4 upon z is equals to 2, then the maximum value of z is equal to. From the inequality of complex numbers, we know that z minus 4 upon z is greater than or equal to individual mods. So z minus 4 upon z. Or we can write z minus 4 upon z is 2. So 2 is greater than or equal to, this is z, and this can be written as 4 upon mod z. Now let us solve this equation. This will give me 2 mod z is greater than or equal to mod z square minus 4. Or we can write z square minus 2 mod z minus 4, this is less than or equal to 0. And this is a quadratic equation, so mod z will be mod z equals to minus b, that is 2, plus minus under root of b square, this is 4, minus 4 ac, this will be plus 16 upon 2. This gives mod z is equals to, this is 2 plus minus under root 20 is 2 root 5 upon 2, and if I cancel 2, this will be 1 plus minus root 5, and value of root 5 is 2 point something. So if I take negative sign, this expression becomes negative, and mod z cannot be negative, so I'll go with positive sign, and this matches with option B. So option B is the correct answer. Let us now see question number 46. If log to the base 10, 1 plus 2 raised to the power x is equal to x log base 10 5 plus log base 10 6, then x is equal to. Let us simplify this expression using basic log operations. The expression is x plus log base 10 1 plus 2 power x is equals to x log base 10 5 plus log base 10 6. Or we can write this as, let us take x together, so this will be x 1 plus log base 10 5, and this is log base 10 6 minus log 1 plus 2 raised to the power x, and this will be, sorry, this is minus, so 1 minus 1 can be written as, in terms of base 10 we can write log base 10 10 minus log base 10 5, and this is log base 10 6 upon 1 plus 2 power x, or this can be written as log base 10, this is 10 upon 5, this is log base 10 6 upon 1 plus 2 raised to the power x, or this is x log base 10 2, and here we have log base 10 6 upon 1 plus 2 power x. This x will go to the power, and this becomes log base 10 2 power x. Here we have log base 10, this is 6 upon 1 plus 2 power x, and since log base 10 is on both the sides, so this can be written as 2 power x is equals to 6 upon 1 plus 2 power x. And at this stage we will substitute the value of x from options and check which one is the correct one. If I put x is equals to 1, this becomes 2 and this becomes 6 upon 1 plus 2, that is 3. So both sides will become equal. So 1 is the correct value and this matches with option C. So option C is the correct answer. Let us now see question number 47. The remainder and the quotient of binary division 101110 divided by 110 are respectively. These are the options. To solve this question, we will convert this binary number into the decimal number. So let us do that. The number is 101110 divided by 110. So this number is, this is 1, this is 2, 4, 8, 16, 32. So our number is 32 plus 8 plus 4 plus 2. This gives me 46 and this number is, this is 2, 4. So this is 6. Now we have to divide 46 by 6. 6 sevens are 42. Remainder is 4. So let us convert this remainder into binary division. 4 is 100 and this number will be 4 plus 2 plus 1. So this is 111. So the remainder is 100. First we have to tell the remainder and then the quotient, and this matches with option B. So option B is the correct answer. Let us now see question number 48. The matrix A has x rows and x plus 5 columns. The matrix B has y rows and 11 minus y columns. Both AB and BA exist. What are the values of x and y respectively? So we are given here matrix A has x rows and x plus 5 columns. So this is x by x plus 5. Similarly, matrix B has y rows and 11 minus y columns. Also we are given that AB exists. AB exists means this x plus 5 should be equal to y. So x plus 5 is equals to y. Similarly, BA exists. BA exists means 11 minus y should be equal to x. So 11 minus y is equals to x. Let us solve these two equations. So x plus 5 is equals to y. X is equals to 11 minus y. This gives me, if I add these two, this is 2x plus 5 and this side this will get cancelled. This is 11. So 11 minus 5 is 6 and x will be 3. Similarly, if I put this x here, y is equals to x plus 5. So 3 plus 5, that is 8. And this matches with option C. So option C is the correct answer. Let us now see question number 49. If Sn is equals to Np plus n minus 1 q upon 2, where Sn denotes the sum of the first n terms of an AP, then the common difference is. In this question we want the common difference, and common difference is term 2 minus term 1. If I put n is equals to 1, we'll get S1 and this is same as term 1. So if I put 1, this will be P, 1 minus 1 0, so this term will be 0. Term 1 is P. Now S2 is equals to, if I put n is equals to 2, this will be 2P. This 2 and 2 will get cancelled and Q plus Q. This is sum of two terms, that is T2 plus T1. So T2 is equals to S2 minus S1. This is 2P plus Q minus P. This gives me P plus Q. And common difference is T2 minus T1. This is P plus Q minus P. This gives me Q. So the common difference is Q and this matches with option D. So option D is the correct answer. Let us now see question number 50. The roots of the equation q minus r x square plus r minus p x plus p minus q equals to 0 r. This is a quadratic equation. So if roots are alpha and beta, sum of roots is alpha plus beta. This is r minus p upon q minus r minus sign, and alpha multiplied by beta is p minus q upon q minus r. In this quadratic equation, we can see that if I put x is equals to 1, then this will be q minus r plus r minus p plus p minus q, and this equals 0. It means 1 is the root of this equation. Now if alpha is 1, beta is clearly p minus q upon q minus r, and this matches with option B. So option B is the correct answer. Let us now see question number 51. If E is the universal set and A is equals to B union C, then set, this is the set, is same as the set. These are the options. So let us see. Let us understand it by using Venn diagram. Suppose this is a universal set. This is set E, and in this we have a set A, that is B union C. Suppose this is B union C. So this complete is the set A. Now let us see what we want to calculate. E minus A. E minus A means E except this A, everything that is outside here, this is E minus A. So this is the complement of A. Now E minus A dash. E minus A dash means up to here. E minus A dash. This is A. Now E minus A. Up to here, this is A dash. Similarly, E minus A dash, up to here we have A. Similarly, E minus A is A dash. So this whole represents A dash. A dash means this was B union C, complement of B union C. And this equals B dash intersection C dash. And this matches with option C. So option C is the correct answer. Let us now see question number 52. If A is equal to x such that x is a multiple of 2 and B is a set where x such that x is a multiple of 5 and C is a set where x is a multiple of 10, then A intersection B intersection C is equal to. In this question, for A intersection B intersection C, we want the elements that are common to both A, B and C. So in this we are having multiples of 2. In this we are having multiples of 5, and in this we are having multiples of 10. Clearly the multiple of 10 are common to all the three sets. So the answer for this question is option number C. Now let us see question number 53. Alpha and beta are the roots of the equation 1 plus x square is equal to 0, then the matrix product 1 alpha, alpha 1, beta beta is equal to. In this we are given a quadratic equation, this one, and its roots are alpha and beta. So clearly from this equation alpha plus beta is equals to, this will be minus 1, and alpha into beta is equals to 1. Let us now find the product of this matrix. This element will be 1 multiplied by alpha, then beta. So this will be alpha plus beta. Similarly, this will be beta plus beta square. This will be alpha square plus alpha. And this is alpha beta plus alpha beta. Clearly, and this gives me, this element will be minus 1. And this element will be 1 plus 1. This is 2. This will be alpha if I take outside. This will be alpha plus 1. And alpha plus 1 is same as beta. Similarly, this will be, if I take beta outside, this will be beta plus 1. And beta plus 1 is also alpha. So alpha beta. And alpha beta is 1. So answer matrix will be minus 1, 1, 1 and 2. And this matches with option, sorry, minus sign will also be there because alpha square plus alpha is equals to minus beta. So minus alpha beta alpha, this gives me this, and this matches with option B. So option B is the correct answer. That's all in this video. I hope you liked it. Give this video a like, share it with your friends and subscribe to my channel. In next video, I will be there with question number 54 onwards. Thank you.